Hello viewers, welcome back to another video of the DSAT. In this video, I'm going to show you how to make the A and T files, which are the experimental data files, and how you can create those AT create by using the experimental data from the DSAT. And so A means average files, construct average performance, and time course experimental files. So I want to give a brief information about what are the measurements needed in a few experiments. So basically, two types of data provide crucial information related to water use dynamics and growth response. However, sometimes they are expensive and time consuming, so it is impractical to collect these data in all experiments. Many of which are likely to be in farmer fields, the data obtained from these measurements in a few places would greatly increase the confidence in use of models to predict those responses in fields where they are not measured. In particular, water use by crops is highly critical to yield formation and is important in any technology aimed at increasing the productivity and sustainability of soils in rain-fed agriculture. So growth analysis measurements can be taken like 4 to 8 times during season. Generally, these would be taken on station experiment for some, mainly to make sure that you have a good genetic coefficients and can simulate attainable yield or potential yield. So in this way, like we can you can know the above ground biomass, left stem, leaf, stem, knee, seed or ear pod weights, number of main stems, nodes, leaf area index possibly, which is would be your time course, like you will be taking leaf area index at different stages or during your growing season at multiple intervals. So and then you can also go for the soil analysis similarly. So let's open the DSAT here. So first I want to show you how you can copy your files, how you can create a copy of your DSAT. Let's go to the, I'm just taking it as an example here. So just go to the peanut, legumes, peanut, and then just go to the UFGA 7601, and I'm going to create, as you can see, I'm going to create, open this file. So what we are going to do, we are going to name it as experiment number 5. Now we are going to save it. So in this way, now we have two copies of the same experiment, which now close this, and after refreshing it, you will see here your this one UFGA 7601 and UFGA 7605, both with the same names. And in this way, we, if you want to add any changes or we want to check, so in this way you can create a copy of your experiment. So let's see what is all about this experiment. Let's have a brief look at the experiment. So this experiment is all about the fields, uh, the peanut, and the station was Gainesville, Millhopper fine soil. The cultivar used was flow runner, and the planting was done by on 1976. Irrigation, it was irrigated experiment. Now let's go to the fertilizer section. In management, there's only one dose of fertilizer, which is about 11 kg of nitrogen, as legume crop needs less nitrogen. So we can also look at the description here about this experiment here. So now we have I have created an Excel file. So this is the summary file for with me available. Let's open this file. So in this way, so the first column should be the treatment number. It should be always the treatment number. Treatment number is we are going one treatment or two treatments. So in this case, for example, this one, and what were the different parameters, that was only calculated once. So like harvest index, harvest weight at maturity, combined weight at maturity, So these were all the things. So if you want to know what this code has, what this code represents, you can go to DSAT HWUM, you can go to codes, and then you can HW for UM. So this is the weight, unit weight at maturity. So in this way you can look at the different codes here. So first I'm going to create the, now if you see that no data files are linked with this file, but with the, if you look any other experiment, if you click on data, you can see it has one P, and P and stands for peanut and A for average file. So I want to make this for file into my DSAT. So for this one we will click on experimental data, and then we will click here on A, which file we are going to create, either A or T. So now I will click on open. This is a file. So already open. If I want to edit any file, you can open here, or import data. I will click on import data if I'm, so it's on my desktop. So this one is a summary data. Click on open. Yes. So we can also do one more thing. So in this case we have, if we want to add some details here, we can use this edit file header. We can click here. So now the experiment name, we have to give the same name of the experiment, UFGA. UFGA 7605, with which we want to link. So it was the A file, this was for peanut. So my experiment, you can say A summary data, press OK. So now you can see here it is already created UFGA 7605 PN for peanut and this relates to A average file. So similarly we right click on here, this is TR treatment number, press OK. This is PWAM, we can search for it by clicking PWAM. So you can see here PWAM, this pod ear panicle weight at maturity. Similarly right click on the third one, we can also type it here manually, H AM. So this will represent number at maturity, press OK. This is HWAM, harvested yield at harvest maturity in kilogram per hectare, and this one is the CWAM, top weight at maturity, and this one is HWUM, unit weight at maturity. So I want to delete this column, so again I'm click here and I will select this delete selected row. Sorry, I want to delete this row. So yes, so now I'm going to create save file. So it will be created in the peanut folder under where all the X files are available, A and T files. So it would name as PN peanut A file UFGA 7601 with the code save, and just I want to exit from it. I've already saved my file, so if it appears here, so now I'm going to refresh it, and if I click here and go here, it will show me my file. So we can see here that it created the treatment 1 and 2. So So in this way we have already created our A file. So let's run this file. Run model. Okay, analysis. I will just go to the overview, view. So in this way you can see here we have two, the final yield is around 4493, and what we are comparing here is this yield at harvest maturity. The simulated was 4493 and Meyer was 5283. Pod year, which was simulated as 5728 and Meyer was 6718, and the top weight at maturity. So I'm going to close it. So if we look at our we have to click here, just click here, we don't have to check the box to see our attached, then we click here edit file. So in this way we can edit some more information in it, but we don't have to edit any information in it. So if we want to view our file, so the line the file required at least 2 line headers actually, with additional optional blank lines. So this is the historic sign line indicates the file type to expect, and the line with this rate at the rate of this sign starts with this indicates what variables and order of variables to expect. So in this way the order should be, the first should be the treatment number, and then there would be the remaining variables which we have collected during our field. Similarly, let's have a look at the time series data which we have collected over the course of during from sowing to until harvesting. So let's have a look at this Excel sheet in which I have a raw data. So in this way I have this. Similarly, for the same time series data, the first column should indicate the treatment number 1, and then the treatment number 2, like we have a 2-factor experiment, let's say. Then the date should be in this format. If we have the date in the normal calendar form with the month, day and year, then we have to convert this one. So I have already told you one command by which how we can convert this, and then the remaining columns should be the different data we have taken during our course of experiment. Now let's go to the DSAT again, click on experimental data, go to file, wizard. So here we can see that this contains approximately how many, 2 3 4 5 6 7 8 columns and approximately 18 rows. So 18 rows and 8 columns. So this is our T file, this is for peanut. Click on peanut, press OK, and then we will click. So by mistake we have, so now it has created pn my peanut experiment data. We can click here to add more information about it, like the experiment with which we want to, the X file with which we want to link this. So UFGA 7605, this is for peanut. T file, press OK. Now the name would appear here. So clicking on this header file, first go to the wizard, then this file, and then we need to import our data. We can also add manually here. So the first 2 columns will be the treatment and the date. Let's suppose you have a treatment, you have a 10 factors, 10 treatments. So these one basically it indicates about the replications. The one are the replications of how many measurements you have taken. So let's import data. It's on the desktop. This one, click open. Yes. So in this case, my experiment basically only contains one factor, so I need to delete this. You cannot select multiple line, you have to do one by one. So now you can see that before I have selected my adders, but it has changed to some different factors. If this appears, you cannot see your T file in the X file. So you have to either change it manually, or when you are going to save it, or either you can go for here directly and change its name here, UFGA 7601, sorry 7605 peanut, press OK. Now the name would change here. It only changes the header properties. So let's change this treatment number. Right click on it, and then this one is the date. So you have to see which format you are using. 2 digits for the year and 3 digits for day of year. Press OK, and then click similarly for PWAD. You can type it here, which is the port weight. And then AD, this is a grain number per meter square. GWAD, grain weight. Port number. CWAD. GWGD, unit grain weight. Press OK. Now we have to delete this selected row. So if let's suppose you have taken this measurement on the day year 676 and the day of year was 161. So as you take the multiple readings, you have this, in this way you can show only one. So this is for one has a one factor experiment, so this will remain the one. Let's suppose if you have a two factor experiment, then you will add 2 here, and then the same format with the date, the day where you when you have collected this information, and then you can see. So then again you have to go to file, save file, UFGA 7605, save it. So this the file type is PN stands for peanut and T for time series, and then click on save, and then you can click on exit. Yes, it's already saved here. So .pnt, you can save it here. Now it's closed. So now we have to go here, refresh it, and then if you click here, then you can see in data you will see the both A and T files. So as we know that this experiment was only the one factor irrigated, so but in the average file we have added the second met treatment. So now we are going to edit this one. Either you can add manually or by going to the opening this experimental data. So just click here. You can, let me show you the another way of doing this. View file, by opening in the notepad, just select this one, I'm going to erase this. I'm going to save, close this one. So again, experiment, refresh it. You click on this without ticking on the checking the box, then go to data, and then you will click here, you will see this one. So now I'm going to run my experiment. This one, I will refresh it again, run model. Now all my A and T files are linked with this X file. Analysis, plant grow out, plot. So now this grain weight, tops weight have been measured, so this will appear as a bold. Let's see grain weight and top weight how they are changing. Select irrigated because we have only one factor here. Next. So now you can see the simulated is giving this line and the measured was the dots here. So by close it, we can look at all the other factors like plant nitrogen out. We can select multiple options from here. So as there was no nitrogen measurement, top weight, pod weight, we can look at the pod weight, click on next. So you can see the the line shows the simulated and the dot shows were observed. So let's close this experiment, and now I'm going to show you one more thing here, that if we click on edit, so, let's check which cultivar is used in this. Go to management, cultivar, that was floor runner std. Close this one, refresh it once again, select this one, run model, analysis, overview, view, click on view. So now we can see that the yield at harvest maturity simulated was 4493 and measured is 5283. I need you guys to remember this point here, that there was a difference of approximately 800, 4493 and 5283. So let's close this and run it in a glue. Now I will open the glue. Let's click on started glue. This is a peanut experiment, so it uses the floor runner std. This one, click on go. So which experiment, this will show all the experiment which are using this. So I'm going to click this one, UFGA 67605. Click on go. Yes, save. So let's run for 10 parameters, all parameters, 10 runs. So maybe we can also go for 100. Click on update and run glue. So now the 100 runs are completed. Press OK. Cultivar coefficients. Let's look at the cultivar coefficients. So I'm just going to click here, copy these coefficients here, copy, and I'm going to close this one. You can also look at the development parameters, have the development coefficients are changed. So this file will open in the Excel, and you will see that what were the previous, their mean values and their maximum for only the growth. So you can see the pudor is the phenological, so it doesn't change. Only those parameters will change which are we are looking at the growth. So FLSD 22.103. So these all changes related to the phenological parameters. So let's close this one and let's look at the growth and yield. In the growth and yield only you can see how these parameters are changes by running it for hundreds. So phenological parameters development, EMFL, they doesn't change. Only the growth parameters they changes. So SPD, so this change from this value. So let's close this one and go to the DSSAT directory. genotype. I'm going to for peanut grow, select this one, cultivar file, open this file. So the flow runner std, we use the flow runner std here. So I'm going to place the new after running the glue 100 run, where I'm going to replace the previous one with the new one coefficient and want to see what kind of a change it does make. So let's have a look at the where there is a variable these parameters are. So flow runner burn std. So let's look at the png or so we can see that this IB002 flow runner was used here. Let's go to the IB002 flow runner. I'm going to put some space here. So let's paste this one here and let's change this ID flow runner and make it and give it a new name as new. But remember, we have to make it balance. So just I'm going to put a hyphen here. So in this case, this coefficient is not going to be read, only this coefficient is going to be read by the DSAT. So I'm going to save this file, and again I'm going to back update all LST files. Well, we don't have to update all the LST files. Now open this experiment again, edit, click on edit button, and here we are going to click on refresh because it will update the new cultivar, and we will see again if by going on to management. So flow runner std is okay, press ok, cross. So I'm going to refresh it again. So now I'm going to run it. So run model, press ok, analysis, overview. Let's have a look at the overview. So in the previous I had told you that yield at harvest maturity changes from 40, the simulated was 4493 and measured was 5283. Now let's have a look with the new coefficient which we have entered. So now the yield at harvest maturity, the measured was 5283 and now the simulated is 4099. It means it's reduced. If we run for the glue for more runs like 50,000, 10,000 is minimum advisable. So if we run it more, we can see the difference between the simulated and observed would significantly reduce. So in this way we are going to use our, in this video we have told you about how to make your A. I want to add one more thing here. Like if you look at your T file and you have your multiple observations here, you can do one thing by going to the T file. And let's suppose this is your collection about the what you have data collected, your experiment data collected during your during the whole period of your experiment. So we don't have any column for the replication here. So basically this one is written multiple times here because it represents the treatment number 1, and if you can only use the digits here 1 2 3. For example, if you have 3 plots you are and you have taken like 10 readings, then you have to write 1 10 times, 2 10 times, and 3 10 times, and all the variables which you have noted. So in case you have also find out about the soil analysis, like the during the soil nitrogen leaching during the different period, then what you can do that you can go click here on 2 and add a new Excel file here. It should be remain the same, like the first column should be the treatment number, the second column should be the date, and the third number it should be could be any, like it could be any your soil analysis anything. Let me show you something here. If like for example this is nitrogen leaching NDN, So it shows the daily denitrification soil layer in the 10 in 10 soil layer 10, and soil layer 10 means whatever you have selected in your soil layer 10, that represents the soil daily nitrification. So let's say you have also you have collected the N2 NOC cumulative, and so these all other you can add. Instead of adding here, you can add a separate sheet for them. For example, for soil analysis, you can add here either manually or just exporting it directly from the Excel file. So in case if you have some multiple readings, you can add here. Let me show you some example here. I'm going to close it. So yes, so just uncheck this, go to experiments and refresh it. So I'm going to show you one more example already available in the DSAT. If you go to maze, you click here the UFGA 801, just click here and then go to click here data and just open this not A file. We are going to open the T file. I'm going to click here edit, and then you will able to see here in the experimental data that just wait a second, let it open. So in this case you can see here, and the first is the treatment number. Like for the treatment number 1, they have taken the multiple readings during this date. So what does this date means? I'm going to explain it again. The 82 means the year 82, and 057 is the day of year. So if you have taken the normal, like on the 1st of March 1 3 or in any other format 2003, then you have to convert this into by using in Excel sheet with the basic formula I have already shown you in the previous one of the videos. So or maybe you can get it from the Google, or I'm going to upload it in the description also, the Excel basic how you can convert dates easily, so by using a simple basic formula. So then 82 057, this is our first reading for treatment number 1. So it should be in only 1 2 3 sequence. So they have here 6 treatments. So they have taken multiple readings at multiple times. Like from treatment number 1, they have taken shown this one reading from this date, and this is the different. You can see leaf area index, and you can see go here has whatever you have. So in the second, they have added this soil water. Let's click here. What is it? In the same way, we have to, this is the soil water, soil layer 1 cubic centimeter per cubic centimeter. So you can see here this is 1 1. It means they have taken only 2 readings for the soil water, and similarly for soil water 2D, soil water 3D, 4D and 5D. So 1 1 means they have taken 2 readings. So you cannot add here anything like your block number 1A 1B. You have to add only 1 2 3 digits in the digits. So this is a very key point here. So in this way you can add multiple sheets here depending on your, let me show you what does the SW1D shows here. Let's close this file and uncheck it, go to experiment. It's better to refresh it always. 8201, I'm going to run this, run model. It will take a few time. As you can see, there are the 6 treatment. So go to analysis, and then I'm going to, as they have soil water, we have to look for the soil water dot out. We can go to plot. So you can see the soil layer 1 SWD means 0 to 5 centimeter. So you can see here this is the depth. Then SW2D means 5 to 15 centimeter. So they have different layers here. So in this way they have, you can see the soil water dot output file here. So you can also see here soil water balance dot out file here. So it will show you the basic information about your soil water dot out. So and similarly you can also look at the soil nitrogen dot out. You can even plot it or view it. Whatever the readings they have measured, it will appear as a bold. They have not measured anything like the soil nitrogen leaching or cumulative, but we can see the nitrogen uptake during the growing season. Select all, click on next. It will show you in the G build the graphical interface. So you can see for the different treatments how the nitrogen uptake was. So we can, even if we click on export, we will have a Excel sheet there. So if you click on the export to Excel, it will, you have your Excel file here. You can see it will make the same graph here, and you can also look at the data here, how nitrogen uptake during the day from 0 until it is harvested at the day 129. So in this way you can also create it here. So just I'm going to close this one. And one more thing you want to see, check either where you can see your A or T file, you have to go to the directory, the C drive here also. So by going to your C drive, you can go there, DSAT, and we have created for peanut. I'm going to click here for peanut, search for the peanut here, and then you can see we have created the UFGA 705. So you can see here, this one is your PNX file, the experimental file. This one is PN. The first two digit represents your peanut crop, and this is the T file, and UFGA PNA. So all these files will be created here in the respective directory folder. For example, now I'm going to open this. You can see here that this is your file here. I have already told you, explained this, how this was created and how when it was last edited here. So you can all look at here. So even you can also make some changes here, and you can click save here if you want to add some like another treatment here, or either you can go through the experimental data. You have both the options here. So in this way we have everything here, like the for maize, fallow, whatever you have work here, you can find out here. So this is all about the creating an X, A and T files and the basic information about it. Hopefully you enjoy the video. If you have any questions, please post your questions in the comment section, and we will try to answer your questions. And definitely if you are facing any error, we will try to resolve, and we will try to make a separate video for any errors if you are facing any errors. Thank you very much.